Hey guys, it's Jensen, and we are back for another screencast. And this is the momentum. So I'm gonna title this momentum for the screencast. But what Mr. Day just wants us to do is to find the total momentum before collision. Before collision, which is if we take out the velocity vectors, will be this one, the yellow one, and the total of the momentum after the collision, which is going to be in this here. This yellow here will be transferred to here. And what Mr. D is trying to say is that the momentum of our initial one will be transferred. It was equally transferred, or is equal to the after hit of the collision. So if you can see, if we actually try to do this, doesn't matter where the ball is. It could be here, it could be there, it could be everywhere, but it doesn't matter as the velocity will still be the same. So let's just kind of slow this down. It's just the fast forward, or this one's just fast forward or slow down. So here we're given the momentum. So this is a like regular velocity or constant speed. So we're not accelerating. And you can see there the momentum. I took off the velocity vectors. So let's play. See the yellow transfers. I'm not sure if you can also see it over here. That, so you can see it transfers over to 2, and we can see it from here. Next we are given the velocities. Now if we have both two velocities going this way and going that way, it doesn't really matter, but our velocities here, okay, so our velocity, what Mr. Day wants us to do is the relationship of mass and velocity of momentum. How does it both affect momentum? Well, both affect momentum because they both multiply to each other, because they're both proportional. So you have to make a graph. If you have to make a graph, it's gonna go this way. It's gonna go straight. And so I want to start off with the mass. So the mass we're increase. As you can see, the momentum is increasing as we increase the mass. So the more mass it has, the more height and momentum. Okay, if you see here, boom, woohoo! It's a transfer of momentum, and it's very directly relatable. Now, if we still have the same mass, and we increase the speed, now we can see that the velocity and the momentum also go hand in hand, and it also transfers. It transfers back to 2. So that's how we know, and you can even see it from the momentum value. And there's even the center of mass, and it's all this good stuff, but still we can see that the data as we are given here is a lot. So if you actually just change the velocity, I don't know, to 5, oh, that's too small, 1, the mass, its position is 6.6, it doesn't matter, and we could play this, same thing. So you can see it right here, like they just change. Or if you change the mass to, I don't know, 5, then we can see that, boom, the momentum changes. So it's all about numbers here, but we get the concept here. It's just finding the momentum and the relationship of mass and the velocity.